Welcome, Algebra 2 students, to the homework help video. Let's jump right into this. We're going to start on page 90. The first section is numbers 20 through 25. The directions say that x and y vary directly. So for these 6 problems, we're going to use our model for direct variation. Okay? It says that x and y vary directly, and they want you to write an equation that relates the variables. So here we go. For numbers 20 through 25. They are all direct variation, so we're going to use this model here. Anytime you're asked to write a direct variation equation model, a direct variation equation, you're going to have to find k first. Well, first of all, actually, you have to make sure you have the correct model. Now we have the right model because these numbers are direct variation. Next, we have to solve for k. So where the y is, I will substitute 5. Where the k is, or where the x is, I will substitute 2. Now divide both sides by 2, and you'll get this, 2.5. And now that we know what k is, we pick this number up and we put it in for k. So our answer is y equals 2.5x. Now I think they had a fraction for their answer. They used 5 over 2, which of course is the exact same thing as 2.5. Okay, moving on to 21. Okay, we are going to write a direct variation equation. Thus, we need this model right here. Now, the first thing you do is you solve for k. So where the y is, I will substitute 6. Where the x is, I will substitute -4. Now, divide both sides by -4. These -4's cancel, and k equals a positive divided by a negative is negative. 6 over 4 is 3 over 2, or 1.5. You're welcome to use -1.5 or -3 over 2 or -1.5. It doesn't matter, okay? So here's what k equals. We're going to pick this number up and put it in for k right here. So our answer would be y equals -1.5x. And there is our answer. Okay, moving on to 22. The directions say to write a direct variation equation. So because it's direct variation, here's the model we'll use. After we decide what model we're going to use, we then solve for k. So in order to solve for k, where the y is, I'm going to substitute 10. And where the x is, right here, I'm going to substitute -5. Now divide both sides by -5. 10 divided by -5 is -2. And of course, -5 divided by -5, they cancel out, leaving you with k. So now that I know what k equals, pick it up and put it in for k right here. Your answer is y equals -2x. So that is a direct variation equation. Or you can say it's an equation that relates x and y directly. Number 23. Okay, we're going to write a direct variation equation. So here's the model we're going to use. It's direct variation. The first thing we do after we decide what model we're going to use is we solve for k. So where the y is, I'm going to substitute 3. Where the k is, or where the x is, excuse me, I'm going to substitute 12. Now divide both sides by 12. 3 divided by 12 is 1/4, or I'm going to put 0.25, the same thing. So 0.25 equals k. Now that I know what k equals, I'm going to pick this number up and put it in for k right here. So y equals 0.25x. And that is a direct variation equation. Alright? Moving on to number 24. Okay, let's write a direct variation equation. This direct variation, so we're going to use this model right here. The first thing we do is we solve for k. So where the y is, I'm going to substitute 0.9. And where the x is, I'm going to substitute 0.1. Now divide both sides by 0.1. So 0.9 divided by 0.1 is 9. So 9 equals k. Where the k is right here, I'm going to substitute 9. Because k equals 9. So there's my direct variation model, y equals 9x. Number 25. They want us to write a direct variation equation, so it's direct variation. We'll use that model right there. We're going to solve for k first, so where the y is, I know what K equals, I will pick that number up and put it in for K right here. And so there's my model. Alright, y equals 1/2 x or 0.5x. Okay. Okay, let's take a look at some word problems here. Number 26. Now let me stop and say there's nothing wrong with me giving you word problems that we've not covered in class because A, you should always be challenged in your homework. There's nothing wrong with that. B, if I go over the problems and teach you how to do them, then you're still okay. So that's what we're going to do here. And so here we go. To be able to see your complete reflection in a flat mirror, the mirror must have a minimum length of m inches. Moving closer or further back doesn't change the amount that you see. Now here's the important sentence. The value of m varies directly with your height h. Now it's got to be in inches, by the way. Your height has to be in inches. Now there's the key to the whole thing. Read it slowly. The value of m varies directly with your height. So m varies directly with your height. Look, if I said y varies directly as x, you would use this model here, right? Y varies directly. Sorry guys, I'm really sloppy. You know that when I write, but y varies directly with x. So if it says m varies directly with h, then it's m varies directly with h. If it would have said m varies inversely with h, then m varies inversely with h, just like y equals k over x. Same thing, okay? So that's a big help, what I have right here, okay? Because I now have a model I can use, or kind of a model. Now, they want us to find a linear model for the minimum mirror length in terms of the person's height. So they want us to find a model here. Well, I've told you what to do when you're asked to find a model or a direct variation equation. The first thing you do is you solve for what? K. Alright? So here we go. M stands for what? The mirror must have a minimum length of m inches, so m is the length of the mirror. So look right here. I have a 34.5 mirror. Put that in for m. Now that 34.5 inch mirror allows me to see a person that is 69 inches tall. Do you see it right here? Look guys, a person 69 inches tall needs this long of a mirror. So I put this in for my length of my mirror. I put this in for the height of the person. Now divide both sides by 69. I'm grabbing my calculator right now. 34.5 divided by 69 gives me 0.5. I should have known that. So 0.5 equals k. So now I know what k equals. Pick up 0.5 and put it right here for k. So there's your model, and we're almost finished. Okay? There, we did what they said to do. We wrote a linear model, okay? Now, what is the oh, by the way, when it says write a linear model, you might be thinking, Mr. Arrow, it did not say to write a direct variation equation. And you're right, it didn't. But remember in your notes, I taught you that a direct variation equation is always linear. I taught you that. And up here it said m varies directly with your height, so I knew I had a direct variation equation, and I knew that was okay, because direct variation equations are linear. So this is my linear model. Now look at the last question. What is the length that you need to see your own reflection? Well, I'm about 5 foot 10 inches. So each of you, this will be a little different for me. I'm this tall, so 5 feet would be 60 inches. Plus 10 more inches, so 70 inches. So for me to find the length of the mirror that I need, I would take 0.5 times 70. So I need a mirror that is 35 inches long. Okay? 35 inches long. There we go. So the last part of this problem will be different for everyone, depending on what your height is. Okay, hope this makes sense. Let's try another one. The number of calories a person burns in minutes. Let me read that again. Sorry, guys. The number of calories a person burns and time has to be in minutes. Okay, and by the way, the weight matters too. So right now for this problem, we're going to be dealing with a 150-pound person for the rest of this problem, okay? Now listen to me. Nowhere in this model do we have to put in the number 150. Okay, that's just established for this model that we're about ready to find right here is for a 150-pound person, okay? Alright, now here we go. So, write a linear model that relates C and T. So here's C and T. Let's write a linear model that relates them, okay? Are you ready? Here we go. It says linear model, but we can write a direct variation model because direct variation is linear. Plus they tell us we have direct variation up here. So, a 150-pound person burns off 75 calories. I've got to solve for K, guys, okay? By sitting in class for 50 minutes, so just by sitting you burn calories. Now divide both sides by 50 and you will get 1.5. Alright, so that's what K equals. So where the K is right here, I'm going to go ahead and put 1.5. There we go, so there's my model. Now, that's my direct variation equation, which is also linear. Let me check the book real quick. Actually, I did not check the book for this one back here. Let me look real quick, and yes, that is correct. And now let me check this one here. And 27, yes, that is correct. So there we go. Now, we've written our model. Now, how long? Come on, guys, look. How long? So we're looking for time. We're looking for time. How long must a 150-pound person sit in class to burn off this many calories, which is about equivalent to eating a small chicken pot pie? Okay? Now remember, it's important that they told you the person weighs 150 pounds because this model right here is only good for a 150-pound person. So you've got a 150-pound person sitting in class who wants to burn off 545 calories. So where the C is, I'll put 545. And now we're going to solve for T and see how long he needs to sit in class. So 545 divided by 1.5. And don't forget, time is in what right here? Minutes. So when we solve for T, it'll be minutes. I'm getting 363 and a third. 363 and a third. Now if you want that in hours, of course, then just divide that by 60 and you'll get 6 hours. And let's see, 6 times 50 is 300. So we would have 6 hours and let's see, 366 hours and 3 1/3 minutes. Now if you don't like that, you're welcome to leave your answer just like this, as long as you label it minutes. I don't really care. Okay, but there we go. Alright, I hope that makes sense. Let's move on now to page 529. Page 529. Now listen to me carefully, please, students. The first 3 problems, the directions say that x and y vary inversely. The first 3 problems, numbers 7, 8, and 9, the directions say that x and y vary inversely, and they want us to write an inverse variation equation. So because they vary inversely, we're using this model here. Okay? You've got to have your models memorized, guys, and you have to know when to use each one. Alright? It's very important. So here we go. I'm going to write an inverse variation equation. So the first thing I have to do is find k. So where the y is, I will substitute -2. Where the x is, I will substitute 3. Now the 3 is dividing to the k, so to get rid of this 3, I'm going to multiply both sides by 3. If I multiply -2 times 3, I get -6. If I multiply this side by 3, the 3's would cancel, leaving you with k. So now that I know what k equals, I'm going to pick up -6 and put it in for k up here. So y equals -6 over x. Alright? Now, I know what they have here for an answer. I do not like it. answers in this form. This is very unusual. Almost always in most math books, you want to have y by itself. For some reason, they decided to multiply both sides by x. So x times y is yx. And negative 6 over x times x is negative 6. So our answer here is the exact same answer as they have. It's identical. But I do want this answer here. Okay, this is the kind of answer I want for your tests and quizzes right here. So there's our inverse variation equation. Alright, number 8. The directions say that x and y vary inversely, and they want us to write an equation that models that. So we're dealing with inverse variation. So we want this model right here. First we're going to solve for k. Alright, so where the y is, I substitute 6. Where the x is, I will substitute 4. Multiply both sides by 4. 6 times 4 is 24. And on the right side, your 4's would cancel, leaving you with k. So k equals 24, so pick up 24 and put in for k right here. And there is your answer. And of course, they're going to have yx equals 24. Alright, so there we go. Number 9. X and y vary inversely. Write an equation that relates them. So we're dealing with inverse variation. So there's the model I'm going to use. For y, I'm going to substitute 1. We're going to solve for k first. For x, I'm going to substitute 5. Now multiply both sides by 5. 5 times 1 is 5. K over 5 times 5 is k. So k equals 5. Since k equals 5, we're going to pick up 5 and put it in for k right here. So y equals 5 over x. And that's your answer. They're going to have yx equals 5. We're going to have this right here. Now numbers 10, 11, and 12 is a little different. The directions say that x and y, that z varies jointly with the product of x and y. Look at the directions, guys, in the book. You can look them up yourself. Page 529. Numbers 10 through 12, the directions say z varies jointly with the product of x and y. So z varies jointly with the product of x and y. So there we go. That's the model I want to use for 10, 11, and 12. Alright. So here we go. Let's write the equation that models the situation. So I'm going to solve for k. So where the z is, I'm going to substitute 2. Where the k is, I will put k. For x, I will put 3. And for y, I will put 8. Now let's simplify this right side. 3 times 8 is 24. So I have 24k. 3 times 8 is 24. 24k. Now divide both sides by 24. And you're going to get 1/12, which is totally fine to use for k, alright? Or if you want the decimal, it's going to be 0.083 repeating. I'm going to use 1/12. So I pick up 1/12, I put it in for k right here. Z equals 1/12. XY, now I don't have an answer in front of me. Let me look at the answer key here and see what they have. And that's exactly what they have. Moving on to number 11. Okay, Z varies jointly with the product of x and y, so I'm going to use that model there. We're going to solve for k first, like always. So where Z is, I'm going to put 3/4. Where x is, I'm going to substitute -5. And where y is, I'm going to substitute 2. Multiply these two together. Now I have 3/4 equals -10k. -10k. Now with your calculator, we're going to take 3/4 and divide it by 10, or divide it by -10. And we're going to get -0.075 equals k. Now if you'd like a fraction, then you would have -3/40. Either one of those two are acceptable. So because this equals k, we're going to pick it up and put it for k right here. And you say, Mr. Arrow, sometimes use a fraction, sometimes you don't. I know, guys. It really doesn't matter. It really does not matter. I'm more inclined to use decimals when it comes out to an exact number like this. The last problem, it was repeating, so I used a fraction. But really, either way, it's fine. Let me check so here's our answer right here. Let me check the answer key. And they had the fraction. x and y. So so we're going to use this model here, and we're going to solve for k first like usual. So where the z is, I will substitute 4. Where the x is, I will substitute 1. Where the y is, I will substitute 1/2. Obviously, 1 times 1/2 is 1/2. Now divide both sides by 1/2. 4 divided by 1/2 is 8. 8 equals k. So where the k is, I will substitute 8. So my model is z equals 8x, y. And that is a model that varies joint variation for x and y. Let me check the answer key real quick, and that is correct. Now we're going to do quite a few word problems, guys, so let's really do the best to get these, okay? The time t you need to type a paper varies inversely with the rate r. Stop right there. T varies inversely with r. Got it? So t varies inversely with r. Now, they want us to the directions say, I'm sorry, students, if you look above number 13 in your book, please look above number 13. They give you directions for 13, 14, and 15. Write an equation that relates the variables. So we're going to write an equation, so we have to solve for k, alright? So, we're typing 40 words per minute, alright? That's your rate. T is time in minutes. R is your rate, how fast you type. So, where T is, I'm going to put 50, because you're typing for 50 minutes. And rate is 40 words per minute. Now multiply both sides by 40, and we'll get 2,000 equals k. So our model would be, pick up this and put it in for k. Our model is T equals 2,000 divided by r. And there we go. Now, they're going to have RT equals 2,000, which is fine, but I want this answer here. Number 14, the pressure P the pressure P varies inversely with the area A. So P varies inversely with A. P varies inversely with A. Let's read it. The pressure P that a 160-pound person's shoe exerts on the ground when walking varies inversely with the area of the sole of the shoe. That does make sense. If you're walking on a real small, almost like a stilt or something. If you're a person walking on stilts, the area is smaller. That you're standing on that piece of wood there, walking on a stilt. Well, I'm not gonna show off my drawing skills here. Sarcasm intended, but that does make sense. When the soles have an area of 40 square inches, the pressure is 4 pounds. Let's write the inverse variation equation. So the area is 40, so where A is, I'm going to put 40. And the pressure is 4 pounds per square inch, so put a 4 over here. Multiply both sides by 40 and you'll get this. So there's my answer. So not my answer, there's my k value, my constant. So pick this up and put it in for k, and your answer is P equals 160 over A. Now they're going to have AP equals 160, or PA, but we're going to leave it like this. Number 15. Now this is really interesting. They're really throwing a pretty tough problem at you here, so listen carefully. R varies directly with L, and at the same time it varies inversely with A. So let's go really, really slow. R varies directly with L. But R also varies inversely with A. So just put it over A, and there we go. So R equals KL over A. Now what that means is R shock to you, but let's look at it again. R varies directly with L, so R equals KL. And R also varies inversely with A, so A goes in the denominator. And there's our model. Now, let's solve for K. Okay, let's solve for K. R is what? The resistance. So it has a resistance of 0.025 right here. So there's my R. L stands for the length. Look what I have, a 500 centimeter piece of wire. So how long is this piece of wire? 500 centimeters. A is the area of the wire. Now look, they don't give us the area, they give us the radius. So we know how to find the area, don't we? Sure we do. Think about it, a wire's round, isn't it? The end of it's round. There's a wire right there. If you cut off the end of it, that's round like that. So, to find the area of the wire, we know the radius is 0.2. So don't put 0.2 in for A, guys. 0.2 is not the area. A stands for area. 0.2 is the radius. But since they gave us the radius, we can find the area. Area equals pi times 0.2 squared. Square 0.2 and you'll get this. Area equals 0.2 times 0.2 is 0.04. Now, in their answer, they left pi, as you can see right here. So, I'm not gonna put 3.14 in for pi, okay? I'm just gonna leave pi like that for now, which is fine. So there's my area. Let's go over it again. Did they give me the area? No, they gave me the radius. So if they give me the radius, I have to find the area. Here's how you find the area of a circle, pi r squared. So for the radius, I put 0.2. I square it, I get 0.04. There's the area. So I'm going to put 0.04 pi. Now let's solve for K. First of all, multiply both sides by 0.04 pi, okay? So 0.025 times 0.04 gives you 0.001 pi. Okay, so the first thing I did is I multiplied both sides by 0.04, multiply this side by 0.04 pi, and they cancel out, okay? Times 0.04 pi over 1, they cancel out. Multiply this side by 0.04 pi, and we take 0.04 times 0.025, and we get this right here. Now, to get K by itself, we're going to divide both sides by 500, so we have 0.001 pi divided by 500 equals K. Alright, so 0.001 divided by 500 is going to give me, now it should be coming up on your screen. When you take 0.001 divided by 500, it's going to give you scientific notation. I believe it should say 2e to the negative 6. And that just simply means 2 times 10 to the negative 6. So move your decimal 6 places to the left and you'll get 0.0000002. Okay, so really what K equals is 0.00002 pi. Okay, so there we go. Now, for K right here, I'm going to put this number in. So here's what they have. They have 0.12345 pi, then L, all over A. Now their answer is going to be a little different, but I need you to do something for me. Just trust me, I'm correct. What's in front of this pi right here? A 1. If you take 1 divided by 500,000, you will get this right here, which is this right here. So this answer right here is identical to this answer here. And in this situation, I actually I like their answer a lot better. But I'm not going to make that a requirement. This is totally fine, okay? I don't mind. And so there's your answer. Now this is a pretty tough problem. It might behoove you greatly, or it might benefit you greatly to watch it again, okay? But that's up to you. Alright, moving on to number 16. We have 4 problems left. is about 6 feet across at its center, and it's said to be large enough to swallow up small fishing boats. Now listen, S varies inversely with R. S varies inversely with R. Now if it would have said directly, we would have written it like this. That's direct variation, okay? If the water speed is 2.5 feet per second at a radius of 30 feet, what is the speed of the water at a radius of 3 feet? Now, listen, the first thing we want to do, even though they don't tell us to find an equation that models this, that's really the first thing you want to do. Sorry for yawning, I apologize. That's the first thing you want to do, because once you get the model written, you can then plug in numbers and get out values with no problem. So the first thing we're going to do is we're going to write a model. Now in order to write a model, we have to solve for k. In order to solve for k, we have to know what S and R are, okay? Well, we have it right here, look. They tell us when the water speed is this, the radius is this, so there we go. The speed S of the water in the whirlpool varies inversely with the radius of the water pool, so when the water speed is 2.5 feet per second, the radius is 30. Now we can solve for k, can't we? Multiply both sides by 30. 2.5 times 30 is 75. So 75 equals k, so we're going to pick that up and put it in for k. Now listen to me, nowhere in the model did they ask us to, nowhere in the problem did they ask us to write a model, but I still felt like it would be helpful, so there's my model. Now look at the question. What is the speed of the water? So we're looking for S. When the radius is 3, so for the radius I'll put 3. So the speed equals 75 over 3. 75 divided by 3 is 25. So the speed is 25 feet per second. That's the speed. Alright. Check our answer, make sure it's accurate, and moving on to number 17. To balance a seesaw, the distance d is inversely proportional or related to the weight. So d is inversely related to w. D is inversely related to w. There we go. D is the distance you're sitting from the fulcrum. Now when they say fulcrum, fulcrum is the middle, okay? The fulcrum where it's balancing, okay? There's the teeter-totter, there's the middle of it. That's the middle. So when it says that it's inversely proportional, the distance you're sitting from the fulcrum, that means how far you're sitting from the center, which in this case is 6 feet, is inversely proportional to how much you weigh. Alright, so that's what that means. So here we go. Roger, who weighs 120 pounds, is sitting 6 feet away from the fulcrum. Ellen weighs 108. How far should she sit from the fulcrum to balance the seesaw? Okay, now listen. It doesn't tell us to write a model, but it's going to be really helpful. In order to write a model, we have to solve for k. In order to solve for k, we have to know what d and w are. Well, they give us a scenario that gives us d and w. Look right here. Roger weighs 120, so we'll put 120 for w. Roger weighs 120, and he's sitting 6 feet away from the fulcrum, so that's the distance. So there we go. So they give us a scenario that allows us to solve for k. Multiply both sides by 120, and we're going to get 720 equals k. So if that equals k, pick it up and put it in for k. So d equals 720 over w. Now, look what the question asks us here in the end. It says, how far from the fulcrum must she sit to balance the seesaw? Okay, and she weighs 108 pounds. So where the weight is, I'm going to put 108. 720 divided by 108 is going to give me 6.6 repeating. So the distance in feet is 6 and 2/3, or 6.6 repeating. And that is the correct answer. Feet, of course, because your distance is in feet and your weight is in pounds. Alright, number 18. The temperature T of an enclosed gas varies jointly with the product of the volume V and the pressure P. Let's stop and write that down. Temperature varies jointly with V and P. So temperature varies jointly with V and P. There we go. Not bad, okay, pretty simple. T varies jointly with V and P. There it is. Now, the temperature of a gas is this much when the volume is 8,000 cubic centimeters. The pressure is this. What is the temperature? So we're looking for T when the volume is 7,000 and the pressure is 0.87. Well, guys, they do not tell us to find a model, but I'm telling you now we need to. It's going to be very helpful to us. If we're going to write the model that models this situation, then we have to solve for K first. We can't solve for K unless we know what T, V, and P are in one scenario. Look at this sentence here. They give us one scenario right here. It gives us everything we need to know right here for our model. The temperature of a gas is 294. When the volume is 8,000. And the pressure is 0.75. Look at that, we can solve for K easily. First of all, take 8,000 and multiply that by 0.75, and we'll get 6,000. So 294 equals 6,000 K. Alright, now we're going to divide both sides by 6,000. And if you type that into your calculator, you're going to get 0.049 exactly. So that's what K equals. So I'm going to pick that up and put it in for K right here. So now I have my model, 0.049 VP. So what is the temperature? So I'm looking for T. What is the temperature when the volume is 7,000 and the pressure is 0.87? Squeeze that in here. So if I multiply all three of these numbers together, 0.049 times 7,000 times 0.87, trust me, you can type it in yourself, you will get 298.41 degrees Kelvin. Alright, and that is the answer. Alright, moving on to number 19. Okay, last problem. The interest I varies jointly proportional to T and P. Interest is jointly proportional, or in other words, varies jointly to T and P. So I varies jointly with T and P. I is the interest that you get out of a savings account. T is the time in years. No, it has to be in years. Don't forget that, okay? Your time has to be in years. And your P stands for your principal, how much money that you're investing or how much money you're putting into your savings account, okay? Now, what is the interest after 9 months? Well, guys, we cannot answer that question unless we write us a model first and find K, alright? So, in order to solve for K, we have to know what I, T, and P are. Well, they give us a nice scenario right here. Here it is. After 3 months, there's your time. So a lot of you are going to put 3 for T, and that's wrong. T has to be in years. So 3 months is 1/4 of a year, 0.25. After 3 months, the interest is how much? The interest is 106.25. And it says the interest on a principal of 5,000, so P is 5,000. So I can solve for K pretty quickly here. First of all, I'm going to multiply 0.25 times 5,000. Alright, so 0.25 times 5,000 is 1,250. Now we're going to divide both sides by 1,250. And I'm typing that in now, and I'm getting 0.085. So there's K, 0.085. So where K is right here, I'm going to pick this up and put it in place of K. So my model is y equals 0.085 TP. So there's the model I'm going to use. Alright. Don't forget, time has to be in years. Now here's the question. What is the interest? So we're looking for I after 9 months. Well, listen, guys. The principle is still the same. They're assuming you understand that. The principle stays 5,000. They want to know the interest after 9 months. So your time is 9 months. 9 months is how much of a year? 0.75. How did I get that? 9 over 12. 9 twelfths. Your principal is 5,000. So guys, it's a calculator problem. Simply multiply 0.085 times 0.75 times 5,000, and you will get the correct answer, which is $318.75. Okay? Guys, I really hope that this homework help video has been a help to you. I know these word problems might have been a little challenging, but for the most part, they're not that difficult. If you have any questions, don't hesitate to